I see some of you already joining into the Nearpod, which is awesome. That is what we're going to be doing today. I'm going to wait a couple minutes to allow the rest of our class to join. Before we get into the Nearpod, though, I am going to share my screen in the Google Meet just to go over some of the problems from yesterday to all know how to do them. We were pretty good on them. The last one, a couple of us got wrong, so I just want to take a few minutes. I'm going to share my screen, so you do want to stay in the Google Meet just so that you can see my screen, and then I'm going to send us into the Nearpod. We're going to work on some practice problems very similar to the stuff that we did yesterday, and then you will notice that there's another assignment posted in Google Classroom. That's the only other thing that we're going to do today. So there's no practice problems from the book. There is no Edpuzzle. It's just kind of a review of everything we've done so far. And then, so once we're done with this class activity, I'm going to move you on into your independent time to start working on that. Looking forward into the rest of the week. Tomorrow, we're going to finish up our last section in Unit 1. Thursday is going to be a Unit 1 review that we're all going to do together. And then Friday is going to be a sort of Unit 1 assessment test. I use the word test kind of loosely because I don't want you to stress too much about it. But Friday is our day to finish up and assess ourselves on Unit 1, and then we're going to move into Unit 2 next week. I'm going to wait a couple more seconds. All of us are almost in here. And again, first thing I'm going to do is share my iPad screen with you in the Google Meet just to review some of those problems from yesterday. So I see almost half of you now are in the Nearpod, which is great. But to see my screen, you are going to want to be able to toggle back and forth. I just want to review some of those problems, mainly the last one, because that seemed to be the one where the most issues showed up. Mackenzie, I'll send the code through in a minute. Like I said, no, I don't need you right away to be in the Nearpod. If you're already in there, I can see a handful of you are. That is good. Just keep that open in the background. First thing I'm going to do is share my iPad screen in the Google Meet, just to go over some problems. So I'm not putting the link in the chat yet, just so that we're all on the same page. But once I go over these review problems, then I will share the link and the code and get us all hooked in there. Okay, so majority of us are in here now. So again, make sure you're in the Google Meet just so that you can see my screen. I just want to talk about 2 of the problems that we did yesterday. Alyssa, that's fine. I did notice that, but it's all good. Now I know that it's you, so thank you. Okay, so again, you should just be looking at my screen. I'm going to go over the last 2 problems from yesterday. You guys did really well on them, but just to review so that you know the process behind using these scale problems. So I'm given, this is the problem about the Willis Tower. Nathan, I just read your comment and yes, it does. But so our scale from yesterday, they were all the same. It said that 1 centimeter is equal to 100 meters. So then we used that to find the scale factor, and all of you recognized in these problems yesterday that your scale factor was 100 because I took 100 divided by 1. So my scale factor was 100. And these problems from yesterday were pretty easy because they were all the same thing. They all used the same scale factor. But you have to be careful. Some of you are not reading the problem closely. So it said the scale drawing was 4.43 centimeters. So I know that in the drawing, it's 4.43 centimeters. I need to know its actual height in meters. So since my scale factor was 100, we went through and we're going to multiply that by 100, and you should have gotten 443. That's how all of those first 3 problems worked out. Scale factor was the same, calculated that it was 100. So I took my scale drawing, scaled it up by multiplying. The last problem, however, we were kind of split in our answers because it was a little bit different. So I have the same scale. We had that the Burj Khalifa was the tallest building in the world. The actual height is 829.8 meters. We need to know the size of the scale drawing. Okay, and again, I had that same scale, so I'm just going to rewrite this. But you guys all notice that we were using that same scale factor through all of these. So if 1 centimeter in my scale drawing was 100 meters in real life, again, I'm just reiterating the process. draw your arrow, you would do 100 divided by 1. So your scale factor is 100. But the difference in this problem is that it's asking us for the size in the scale drawing. So I know the actual height. So I'm going to make sure I match my units up. If I have meters on the right, I'm going to keep my meters on the right, and I get 829.8 meters. And I'm looking for the centimeters. So this one you had to recognize that you were working backwards. I'm going from the actual size to the scale drawing. So if typically I use scale factors to multiply to scale it up, if I'm scaling down, I'm going to divide. So you should have taken that scale factor and divided by 100. You should have gotten 8.29. Okay, so you just have to make sure you're reading carefully. We all, I noticed, knew the process of taking the scale factor and multiplying, but that's only if you're given the size of the drawing and you need to find the actual length. If you have the actual height and you're scaling down, you're dividing by your scale factor of 100. But overall, those problems yesterday went really, you guys did really well on them. What we're doing today is a handful similar to this. The scale factors are not going to be the same each time, so they're going to be a little bit more difficult, but just pay attention to the language. Are they asking us to find the scale size or the actual size? Okay, so I'm going to stop sharing my screen. So you may now follow that link that's in Google Classroom to go into the Nearpod. I am going to send it through in the chat. So let me open it up. So once you're logged in, you should just be stuck on a screen telling you that you're waiting for the teacher, because the first screen is going to be a problem for you to work on. So either follow that link, or if you need the code, it's BLDEA. So a lot of you are already in here, which is perfect. So we're just going to hang out for a minute to wait to make sure everybody gets in. So use that code, use the link, head into the Nearpod. And like I said, we're just going to do a handful of practice problems with these scale images. And then I'm going to move you into your independent part. Taylor, I appreciate you looking out for my iPad battery. Thank you, thank you. Sometimes I try to see how low can I get it each day. I'm really bad at remembering to charge it. So again, you log in and you should just be stuck on a screen. I'm not going to start it yet because you'll notice that there's a timer, so we're going to have 4 minutes. I'm just going to wait until we are all in. Oh, which is now. Okay, so I am going to hit start. So again, read the problem carefully, find your scale factor, and then ask yourself, are you finding the bigger length you're going to multiply, or are you trying to scale it down to the scaled image you're going to divide? Okay, but here's our first problem. It says, Mark is looking at a blueprint of a skateboard ramp that shows the ramp's length is 11.4 inches. If the scale on the blueprint is 1 inch to 6 feet, find the actual length of the ramp. Again, if you are in the Google Meet, you need to make sure you are also in the Nearpod. If you are having technical difficulties, just communicate that to me. But if I notice your name in the Google Meet and I don't see your name working in the Nearpod, I'm just going to assume you're not doing the work. Completely different conversation, however, if it is some kind of tech information. So you just need to communicate that with me. Yes. Jack, I see your name in there. Again, make sure you're reading the problem carefully. Our information is that the ramp on the blueprint is 11.4 inches. So make sure you're recognizing that it's 11.4 inches. My scale is 1 inch to 6 feet. Find the actual length of the ramp. you are more than welcome to use your calculator. I see some of you doing some mental math on the paper, which is fantastic, but just double check yourself. If you're multiplying something by 0.4, you can't just stick a 0.4 at the end of your answer. So 6 times 0.4. And then if you finish the problem, make sure you're actually hitting the submit button, because if I notice that all of us are submitted, I'll stop us before that time is up so that we're not just sitting. But if you don't hit submit, it looks like you're still working on my end. Okay, we seem to all be on a good track. I am going to share my screen with you again, just to reiterate the kind of work that you should show and the process behind finding it. So you'll notice here, your first step is to always find that scale factor. So I pulled my scale out. And again, we're doing 6 divided by 1. I don't need you to show that step. I'm just reiterating that that's the process you're doing. You want to be aware of that if it's not as easy to divide in your head. Okay, so your actual length divided by the scaled length tells you what your scale factor is 6. So then I took that scale factor and scaled up my scale drawing, which was 11.4 inches. So doing 11.4 times 6 gave me 68.4. Again, feel free to use your calculator. That is perfectly fine. If you're doing the mental math, just be careful. Like I said, when you're multiplying decimals, you can't just stick it onto the end. So some of you were writing 66.4 because you did 11 times 6, but then 0.4 times 6. Just be careful whenever you're doing that. All right, here's your next problem. Dave found the blueprint of his house. It shows the hallway is 4 inches long. If the scale factor is 1 inch to 1.25 feet, what is the length of the hallway? There's a typo in there. What is the length of the hallway in real life? So on my scale drawing or on my blueprint, my hallway is 4 inches, but my scale tells me that if 1 inch on the drawing represents 1.25 feet of actual length. So what does that mean the length of my hallway is in my house? What? Kenny, I don't know why. If you're having issues or if it tells you that the time is up, maybe try to refresh and back out. I'm sorry for some of you that seem to consistently be having tech troubles in here. The only thing I can really tell you right now is to just keep refreshing and try to get back in. And just know that I am recording this, so you'll be able to watch it. If you want me to cover some stuff that you might miss, you have that 10th period open that I can help you. But I do apologize for some of you that are having a lot of tech issues. I know it adds a lot of stress to this. Again, use your calculators. You can try and do the mental math in your head. Some of you are doing that and you're doing it very well on this slide. So I do like that. And wait a couple more seconds. We're all almost finished up. I'm just going to allow those that are still writing another second to finish what they are writing. But we all seem to be getting the right answer here. And if you're done, make sure you hit submit, because some of your answers I really like, but I cannot share them if your answer is not submitted. Okay, I'm going to go ahead and share this with you. So you all got the right answer. If you were a little bit stuck, notice what this student did. They went in and circled what they know. So they recognized that my scale factor here was 1.25. So then I took that and multiplied that through to the scale drawing and got 5 feet in real life. We were all on it on that one. Perfect. Next one. Ari has a map with a scale of 1 inch to 18 miles. To get between two cities on the map, she measures 4.5 inches. How far would that be in real life? So if my scale says that 1 inch on the map actually represents 18 miles, if there's 4.5 inches on the map, how many miles apart are the cities? Perfect. I see some of you going in and underlining and highlighting parts of the word problem. Those are fantastic strategies to work through word problems like this. Pull out all of that important information. Don't worry about any of the other stuff. Again, be careful with your mental math. Some of you, I'm not sure where you're getting some of these numbers from. I can see you writing the correct problem, but then your final answer, I don't know what's going on. Okay, perfect. I see some of you just finishing up and you're all on the right track. So I am just going to share an answer. So don't stress out that you weren't able to finish it, but you were all doing really good with this. So that's why I'm going to start moving faster. So again, we recognize here that your scale factor was 18. So then 18 times that scaled length of 4.5 gave you 81. You were all on it on that one. Perfect. Okay, here's your next one, but I am going to warn you to read this one carefully. It's a little bit different. Just think about those problems I showed you in the beginning of class. Make sure you're reading carefully. Jenny drew a scale drawing of her family's game room. The pool table is 4 feet wide in real life. Using a scale of 1 inch to 2 feet, how wide is the pool table in her drawing? Perfect. I can see a lot of you are fixing the mistakes we were making yesterday on that last problem. Again, it comes down to what are they asking you? Are you trying to scale something up to the actual length, or are you trying to scale something down to the scale drawing length? Okay, if you're still working, that's fine. I'm going to share 2 answers here because there's 2 ways to go about thinking about this. I like both of them. So this first one is what most of you how most of you thought through it. So you saw that your scale factor was 2 because 1 inch times 2 takes you to 2 feet. But they're asking you about the scale drawing, which is why this student then went ahead and took the 4 feet actual divided by 2 to get 2 inches. Exactly correct. If we're scaling down, we're dividing. However, there is another way to think about this, which one of your classmates is noticing. So if you take a look here, it says the pool table is 2 inches long in her drawing because the scale factor is 1/2. Okay, so that idea of dividing by 2 is the same thing as talking about a scale factor of 1/2. So if I go in reverse from feet to inches and do 1 inch divided by 2 feet, that gives you that scale factor of 1/2. So it's the same thing, whether you're thinking in the divide by 2 range or you're talking about multiplying by 1/2. Both really good approaches. But you want to be careful here that you didn't say 8 inches, right? Because they gave you the actual length, you were scaling it down. So if you're scaling it down, you're either multiplying it by the decimal or you're dividing by that scale factor. They mean the same thing. Here's your next one. The blueprint of gym shows the length of a basketball court is 10.4 inches. There's a scale of 1 inch represents 9 feet. What is the actual length? So some of you, again, with your mental math, I love how many of you are going through and writing this out. So you're doing 10 times 9 and getting 90, but then be careful. When you're multiplying by 0.4, 9 times 0.4 is 3.6 because 9 times 4 is 36. But since you have that decimal point in the middle, you want to put the decimal point in the middle of yours. Some of you are just getting tripped up and multiplying that decimal through. 9 times 10 gives you 90. 9 times 0.4 is 3.6. But I'm really impressed with how many of you are going through and writing out that mental math on your paper. Good. I am going to share an answer because we are all right on the ball here. But I do want to show you, like I said, you guys all have the process and some of you are just missing that step where you're just doing some of the math in your head. So I'm going to go ahead and share this just to make sure that you're catching your errors. I don't know why it's not letting me. Okay. So 9 times 10.4, because our scale factor is 9, you can all see that. Again, just be careful in your mental math. That seems to be the only thing some of you are messing up in these. You have the process for the scale factor. You're understanding when to multiply or divide. But if you're trying to do this mental math in your head, 9 times 10 is 90. 9 times 0.4, think about it as 9 times 4 to get 36. But then since there was a decimal, you can write it as 3.6. So some of you are doing 90.36 or 90.45. So just be careful whenever you're going through and multiplying the decimals. Chris is looking at a map with a scale that says 1 inch represents 5 miles. The length of Mount Royal Boulevard on the map is 3/4 of an inch. How long is the actual road? So this one's going to seem more difficult because there's a fraction. But you guys have just shown me that you are on top of it and you understand how to do these problems. So don't let the fact that there's a fraction in here throw you off. You know, some of you tend to think there's a fraction, I can't do it. You know the process. This is no different. If you see a fraction, convert it into a decimal so it's not as intimidating. And just tell yourself to go through the same process you just did on that other page. You all got that answer correct. Be careful with your decimals. If you're trying to make 3/4 into a decimal, you're going to do 3 divided by 4. See some of you writing that as your first step. It's perfect. But remember, 3/4 is not 3.4. So there's a handful of us trying to do that. Again, you guys are doing really well on this, so I'm going to give you one more after this because you've shown me that you guys are killing it. So we'll do one more, and then I'll get you started on your next set. We've got lots of time left over for you to work on your own. All right, I'm going to go ahead and share this with you. So if you're still writing, don't worry, just take a look at the screen. So again, we see that 3/4. If a fraction intimidates you, turn it into a decimal just like this student did. 3/4 is the same as 0.75, and you do top divided by bottom. That's your scale factor. Or I'm sorry, that's the length on the scale drawing. My scale factor is 5. So then 3/4 times 5 or 0.75 times 5 is 375. For those of you that like to do the math in your head, if you want to go through and multiply your fraction through, just take a look at what I did. So I kept it as 3/4. So then if I'm doing 3/4 times 5, you're just multiplying straight into the top. So I did 5 times 3 to get 15, which was just 15 over 4. So if you want to remember your fraction rules, when you're multiplying fractions, you're just going straight across. But it's also fine that you all just turned it into a decimal. I'm not going to be too picky. But this is going to be our last problem. Again, make sure you're reading it carefully. On a scale drawing of a building lot, 1 inch represents 12 feet. The building lot is 114 feet wide. What is the width of the building lot on the scale drawing? I'm really impressed with how well you guys are doing on this. Not only are you getting them right, I'm really impressed with the math work that you're showing, wanting to go through and do the multiplication or the division by hand or in your heads. Very impressed with you guys. We just have to remember, are they asking us to scale it up or are they asking us to scale it down? Scaling up means multiply. Scaling down, you would divide. All right, I am going to pause you because I see half of us getting it right, half of us making a very, very easy mistake. So just to help you guys that are still just reading it wrong, again, you're just going one way instead of the other. It's specifically asking us the size of the scale drawing. So if I know the actual height and I'm scaling it down, remember that's when you're dividing. So you're all finding your scale factors. So I know we're good there. So I need you to just practice reading through and asking yourself, am I making it bigger? Then you would multiply. So some of you did that and got like the 1300 length, but the question is asking us to scale it down. So when you're scaling it down, you're using your division. So I'm dividing by 12. Or if you're someone that's going the fraction route, dividing by 12 or multiplying by 1/12. The same as we did whenever we said divide by 2 or 1/2. we're dividing by 12, or we're using a scale factor of 1/12. So you don't have to understand that fraction part right now. If you're good with the division, just realize that if we're scaling it down, it means we're dividing, okay? But you guys did really good with that. I was a little bit concerned yesterday because some of our answers were all kind of all over the place, but you've shown me that we're really good with this. So you do have 10 minutes left in this period. So what you can do, like I said, there is a second assignment posted in Google Classroom. It's a worksheet. So it has some practice problems from last week and the stuff we did these 2 days with scale drawings. That is the only other thing you need to work on today. So again, no book problems, no Edpuzzle. You're just doing that posted worksheet. Okay, so you can use these 10 minutes to work on that. You can take a break and come back to it 10th period. If you need help on any of it, I'm going to have the room open 10th period. You are also going to notice that there are answer key videos posted for all of those problems. Okay, so if I'm not available, if you're not working on it 10th period and you need to work on it later and you still have some questions, make use of all of those videos that are posted. Okay, but at this point, you are free to leave the Google Meet. You guys did awesome today. And like I said, you can take a break. You don't have to go right into that worksheet if you want to take the 10-minute brain break, or you can just get started on it. 10th period's open for question. Watch those answer key videos to help you. But thank you guys for working so well today. You did great.